Hello, AP Chem students, and welcome to topic 7.3, the equilibrium constant expression. So the learning objective for today is 7.3.a, represent the reaction quotient QC or QP for a reversible reaction, and the corresponding equilibrium expressions Kc equals QC or Kp equals QP. So let's look at it. So the reaction quotient is an expression that allows us to use concentrations or partial pressures of the species to determine in what direction the reaction predominantly proceeds. So thinking back to our last topic about does it proceed towards the reactants or does it proceed toward the products or is it at equilibrium? By expressing the concentrations or partial pressures as a ratio of products over reactants, information about which side of the reaction is favored can be gained. So if you look at this, it probably makes sense to you that if that ratio is greater than 1, we are favoring the products. And if that ratio is less than 1, we are favoring the reactants. But we'll get more into that later. This ratio is called the reaction quotient, abbreviated QC for concentrations, or QP for partial pressures. Use whichever value is appropriate for the data that's provided, and I'm going to show you both here in a few minutes. So if we look at the reaction, Ja plus Kb is in equilibrium with Lc plus Md. Of course, these are just made up. Then we would see that we can write a reaction for Q that looks like this. So again, as a reminder, your products go in the numerator and your reactants go in the denominator. So you might notice that to get this expression, the concentration, which we express as the brackets, so brackets indicates concentration, the concentration of the species are raised to the power of their coefficients. This corresponds to something called the law of mass action. So basically what we're doing here is we're using the stoichiometry to set up this ratio of amounts, right? Okay, I guarantee you that you will have to write this expression on the AP Chemistry exam. This is one of those places where it's very straightforward way for you to earn points, but the details are super important. And so I want to talk to you a little bit more about the details here. So first of all, when writing Q expressions, only include aqueous and gaseous species because the concentrations of solids and liquids do not change in a reaction. When the reversible reaction is at equilibrium conditions, then this same expression is written as K, which is called the equilibrium constant. So what I like to say is if you don't know that it's at equilibrium, you write Q, which I think stands for question. So here's the question, are we at equilibrium? If you know you're at equilibrium, then you write the K. K is constant. Yeah, I know the letters aren't the same, but go with it. So when K is written from concentrations, we sometimes denote that as Kc. But if you see K without a subscript, then by default, it's K for concentration. When K is written from partial pressures, it's denoted as Kp. And we write that a little bit differently, which I'll show you in just a second. K depends on the reaction identity and the temperature, and K is unitless. We're not going to get into why, just accept it. So the details here, again, we're only going to include aqueous and gaseous species. We are not going to include solids and liquids. We're going to be very careful in making sure that we identify our species correctly because the details make a difference there. We're going to be sure that we raise all of the species to the power of their coefficients. So keeping all that in mind, we're going to try a practice. So write the equilibrium expression for the following reaction. We're going to write both a Kc and a Kp. So if you want to try this on your own, pause now because I'm about to show you the answer. So for this, if you're given concentration, which will be expressed in molarity, or they'll give you data that will allow you to calculate the molarity. So for example, moles or grams that you could convert to moles and liters. So if you're given concentration, then you would write a K expression with brackets around each species raised to the power of their coefficient. Remember that we're going to have products on top and reactants on the bottom. So you're going to have NO2 with brackets around it to the fourth, H2O in brackets to the sixth, 4 and 6. And then on your in your denominator, you're going to have NH3 to the fourth power and O2 to the seventh power, again in brackets. Now, super duper important that these are brackets and not parentheses. You need to have those squared off corners to make them brackets. If you're given partial pressures, which will be normally expressed in ATM, you might also see them in torr or millimeters of mercury. And kilopascal sometimes too. We see that a little bit less often on the AP chemistry exam. If you're given partial pressures, instead of using brackets, because brackets denote concentration, you're going to use a capital P. And then your identity for the molecule becomes a subscript of the P. And then you raise that to the power. Notice there are no brackets here. If you use brackets and you're given partial pressures, you will not earn the point, okay? Because brackets are for concentration and P is for pressure. So you want to make sure that you do this here. Now, sometimes you see parentheses written around each individual term. I would encourage you to not do that, because if your parentheses start to look like brackets, it can become a little bit dicey in trying to decide if you get that point or not. Because if you do indicate brackets, you will not earn the point if it's supposed to be a KP and you're given partial pressures. Otherwise, things are the same. That is it. So what should you be able to do with this? It's actually pretty straightforward. You should be able to write a K or a Q expression for a reversible reaction. Again, I guarantee you that this will be on the AP chemistry exam somewhere. It's an easy way for you to get points as long as you pay attention to your details. And I will see you soon for the next topic in Unit 7.